Not tried mine today, so maybe not. No. Okay, let's finish up this PowerPoint for what's it called? Mass wasting. Mass wasting. So landslides and different other falling activities or things moving downhill due to gravity. So we kind of left off here last time, which was Tuesday. Basically saying that anywhere that has significant hills or slopes or mountains is at risk for landslides or mass wasting. Factors expected to increase landslide activity: urbanization and development of landslide prone areas. So cutting down of trees and different vegetation that might be holding your hill together, or creating areas like cement covered parking lots or buildings that aren't going to soak in very much rain, but let the rain run off down to the slopes. That can cause a lot of erosion. So tree cutting in landslide prone areas and changing global climate patterns can cause places to get more rain where they're not used to it, or cause your vegetation or just general instability. Changes cause instability. So we saw this map, which is your danger for landslides, and they have moderate, high, and what is this? High, moderate, and then high. So you can see that here in Texas, we have almost none. I'd be interested to see what this little part right here is, and why they have landslide exposure there. But you can see in the Rockies, they have a lot of incidences and a lot of danger. On the California coast, where the coastline meets the hills, they have a lot of incidences. And then in the Appalachian Mountains, and a little bit up into the Northeast, but this area of the Appalachian Mountains has quite a bit, and the rest of us, not so much. So 7.3, effects of landslides and linkages with other hazards. So landslides can do significant damage. In the United States, 25 people are killed each year on average due to landslides, and damages total $1 billion. I don't know the statistics, but you're going to have some sort of mix of these 25 people, because some of them are going to be killed in like snow avalanches, and others are going to be killed in like actual like mud and rock and mudslide kind of avalanches. So I don't know the distribution there, but remember that snow avalanches are probably included in this number. People hit with or buried by falling debris from these avalanches are obviously going to be your victims. With snow, you have a small chance of digging yourself out or someone getting to you very quickly and digging you out. But if you're caught in a landslide that has to do with dirt or rocks, just the initial impact of that is probably going to be life-threatening, and you're not going to have a high chance of survival. Slides may damage homes, roads, and utilities, and so that's where that $1 billion or greater of damage is from. Any of these things are going to rise that tally pretty quickly. Slides may block roads, impeding travel, or block streams, causing flooding. And some of that flooding and different things involved with landslides can cause disease, especially if they knock out your important infrastructure, like your roads enable your first responders to get there, water lines, electricity lines are going to help people keep their wounds clean. And so if those kind of get knocked out, you could see disease on the rise. If I had to guess, disease caused by landslides is probably not super huge in the United States. You're probably talking about more remote areas where when the landslide happens, you're very cut off from any kind of rescue or standard health facilities. So linkages between landslides and other natural hazards. Landslides can be linked to almost all other hazards. Earthquakes can cause landslides. Volcanoes erupting can cause landslides. Storms can cause landslides. We see this in California in the rainy season. Fires may cause landslides or exacerbate the conditions that can cause landslides. And landslides may cause flooding or tsunamis. And so out of this list, it's hard to find something else that we're not really connecting to landslides. I mean, tornadoes don't really have anything to do with landslides. But pretty much most of your natural hazards can have some sort of link, even if it's a loose link, to landslides and mass wasting. 7.4, natural service functions of landslides. What are the good things about landslides? Sure, mostly bad. There's got to be some redeeming quality to a landslide, right? So landslides can produce deposits that become mineral resources, such as gold or diamonds. The landslides that I'm thinking of don't really affect humans. They happen out in the oceans, such as like the Gulf of Mexico. But we look for landslide deposits in oil and gas exploration. They're called turbidites. And if you can find a turbidite, there's a pretty good chance that it could hold a decent amount of oil and gas inside of it. And so we do look for those as far as mineral resources. Creation of new habitats, forests, and aquatic ecosystems. It could increase plant and activity, animal diversity. Landslides can flood certain parts of the river. They can create new kind of areas that weren't there before. And that can all be good stuff. But in general, you can see this is a little bit of a stretch. There's not a lot of good things about landslides. Very rarely after a landslide is somebody like, great, I'm so glad that happened because now the plants and animals are more diverse. It's a little bit of a stretch. 7.5, human interaction with landslides. They are a natural phenomenon. They're going to happen with or without humans. That being said, we do a lot of things to make them happen more often. Expansion of urban areas, transportation networks, and natural resource use. Grading of land surfaces that increase instability of surfaces. Maybe they should have said decrease stability. But anyways, we go in, we start to change the land, we cut down trees, we bulldoze hills, we kind of make the world to our liking, and sometimes the world doesn't like that and it changes itself back. So we get landslides as a result. Humans can decrease incidents though, building stabilizing structures, improving drainage. All of these things can help prevent landslides. And once we move into a place and we find out it's landslide prone, hopefully the people there make the right decision and start to implement things that can help protect them from that. So timber harvesting landslides, we did see pictures earlier in the PowerPoint of like an entire mountain that had been clear cut and all the trees were removed. That's not going to be good for the stability of the slopes in that area. You're going to start to see more and more landslides happen. So they say major environmental and economic issues in some regions. Two controversial practices: the clear cutting, removing of all the trees of a defined area, and then road building. Road building increases erosion, soil slips on geologically unstable land. It interrupts surface drainage, alters subsurface movement of water, and changes distribution of earth materials. And so it may not seem like a big deal building a road, but when you build a road on a slope, on a hillside or a mountainside where that road was not there, you are clearly going to change things. You're going to change the way that water moves, the way that the land and the soil erode, and you're putting your own materials in there. And so it's generally going to make things less stable unless you make a clear effort to counteract that. Let's see, urbanization and landslides. Human activity is most likely to cause landslides in urban areas. Removal of that anchoring vegetation, the trees that have the deep roots that kind of hold the hillside in place, construction of roads, building at higher elevations, grading things. Grading means like changing the slope of a hill, building up a hill to build like a foundation for a building on, or cutting down a hill to kind of make your foundation fit a little bit better within the terrain. So sometimes we cut benches into slopes for home sites, and that sounds good, but generally your home site is flat, but the hill that's right next to it will be more steep than it should be. And so you have these over steepened slopes, which are eventually going to erode and degrade, and you could have a landslide. Lawn irrigation and septic systems are going to change the way that water flows and moves around. And then buildings and fill materials are obviously going to change what your ground is made of. And so all of these, if you don't consider landslides as a possibility, can create a bad situation. Now, if you're aware of this and you have a proper engineer and they're working with local geologists to make sure that they're kind of considering all this stuff, human activity doesn't have to be bad for all of these things. It just takes a little bit of planning and a little bit of thinking about what you're doing and why you're doing it. So here's an example of grading and making these like terrace steps. So you have a hill here, and the hill's not that steep, but you want to build a house on the hill. And your house needs to be flat. You need a flat foundation for your house. So what we do is we cut into the hill and take that cut out and come and move it down the hill. And we make this flat kind of step. It almost looks like stairs as you come down. We do this in lots of areas. It's not just for home building. If you want to farm a hilled area, farming on a hill isn't necessarily the best method to use. And so farmers will kind of make these steps in a way. But the problem is at the transition in between each step, I now have a super steep hill where the general slope is not that steep. And so what's going to happen is this hill is very prone to weathering and erosion. And if enough of it happens and becomes unstable, you could have a landslide and it's going to come down and destroy this house. And so this slope here needs to be really reinforced, and you need to think about all the ways that it could fail, or you might have big problems. Same things with this up above this house. This is just a natural kind of cut that they've made, but you can see the cracks developing, and this material could easily cause a landslide and take out the house below it. So 7.6, what do we do if we still want to build a house, but we don't want a landslide to come and knock it down? We can minimize the hazards. To minimize landslides, it is necessary to identify areas where landslides are likely to occur. If you're not even thinking about it, odds are you could be making a big mistake. The same thing goes with floodplains. If you just buy a house and you're next to a creek and you don't think about floods even once, odds are you're going to get bad news whenever it decides to flood. If I live in California, I'm going to think about landslides. Am I near a hill? How is this going to happen? Like, if the landslide does occur, where's it going to go? Those are important questions to answer before you start to build. Design slopes of engineering structures to prevent them. So if you have to change the slope of the land, you need to actually do some engineering. You need to sit down with someone who knows what they're doing, who has the math background, and can kind of figure out how steep you can make your slope with what type of materials and what type of support to keep it from having a landslide like you don't want it to happen. Warn people of impending slides. So if we go back just one slide, I believe, we have this picture here. These cracks are obviously visible. This is something that any trained engineer and geologist could look at and say, this poses a risk to danger. The people in this house and the people in this house probably need to be warned about it. And so if you don't tell these people that it exists, they may not know. They're not trained. They're not geologists. They may just look and see the hill behind their house. But once you start to tell people, then they can be aware and hopefully make better decisions for themselves. Control slides after they have started moving. Not every landslide is super fast and happens in just a couple seconds. Some of them go slowly or happen in stages. And so you can bring in building materials, and sometimes it's just as simple as like those concrete highway dividers, and you just put a physical barrier there. And if the landslide's not too big or too crazy, you can kind of control where it's going to go, or hopefully shore it up and try to stop it. Best to avoid development on high-risk sites. That's the most preferable and the least expensive thing to do. Goes back to number one, identify areas where landslides are likely to occur. And if you identify those areas, let's just go ahead and not build there. And that goes with almost every hazard. If this is a volcano and it's likely to explode, I shouldn't build my house there. If there's a beach that's likely to get hit by a hurricane, I shouldn't build my house there. If I'm living in New Orleans and I'm out like near the Gulf of Mexico and it floods all the time, I probably shouldn't build my house there. And so that's the least expensive and the most preferable way. You stop all the problems from the beginning. obviously there might be somebody that's like, I really do want to build my house there, but you just say, hey, build your house up the road and you can come visit here anytime you want. You don't have to live right on the beach. You can just come visit the beach. But that's okay. We got to live somewhere, and there's always somewhere that's everywhere you live, you're gonna have some sort of danger going on. So identifying potential landslides. What are you looking for when you're trying to see if you have a potential landslide area? The crescent-shaped cracks, we kind of saw that in the drawing. Terraces or hillsides. Tongue-shaped area of bare soil or rock on the hillside. We saw those in the previous pictures from the other day. We have a hill that's basically covered with trees and one area that has no trees in it. And so you can tell that the rocks have slidden down. Slidden? That's not a word. The rocks have slid down and took out the trees on their way. And so that bare soil is a good indicator you've had some sort of rock or landslide. Large boulders or talus pieces piled at the base of the cliff. Yeah, if I got a pile of rocks at the base of a cliff, I know that they fell there. Someone didn't pile them up because they thought it was fun. They fell off the side of the cliff. And so I don't want to stand near that cliff or build anything that I think is valuable near that cliff because likely more boulders are going to fall down on top of it. A linear path of cleared vegetation extending down a hill. You may not always see the boulders and the rocks that have fallen off, but if I see the damage that they've caused, basically a whole bunch of trees being knocked down where there's not really anything else that could have knocked them down, that could also be a good indicator that I have a potential for landslides. Exposed bedrocks with layering parallel to the slope. This is basically just saying I've got a bunch of different layers, and the layers are oriented in a way where it could be like beneficial to landslides, I guess. Maybe that's not the right wording, but I've got this slope. If all my layers are layered like this, they're nice and flat, and if one layer is kind of weak up here, that doesn't mean it's going to slide down the entire slope. But if I have this slope and my layers come like this, and that's what they're talking about being parallel to the slope. If I have a weakness in this layer right here, this whole piece could slide down and cause a huge landslide. And so how your subsurface is kind of oriented compared to your slope can be a big deal. What else do we have? Tongue-shaped masses of sediments at the base of the slope. This is just like your talus piles. An irregular land surface at the base of the slope. Anything that kind of looks out of ordinary. You don't have to see the landslide itself happening. You can look for evidence that could only really be explained by a landslide anywhere along the hill. So, can use to create slope stability or landslide hazard maps. Can use to create identifying potential landslides. Okay, so what they're saying here, they're using any of these indicators that they're looking for. They're using those to create a slope stability or landslide hazard map to kind of figure out where your landslides are likely to happen. So here's another example of that. We have a steep hill. We have this nice bare patch right here. There's no reason the trees wouldn't grow there. The trees did grow there, and then they got knocked down by the landslide itself. You can also see the pile of rocks down here at the bottom by the landslide. And who knows, this pile might have even extended out onto the road and blocked traffic before somebody cleared it up. It's hard to tell at this point, but if it didn't go out onto the road, that's pretty lucky because it came right next to the road. So, yeah, that's what you're looking for there. Landslide hazard map. So this is what we're talking about. You look for the places that show signs of landslides. You place them on a map, and you kind of create this nice overview of where you can expect your landslides to happen. So this is obviously on the coast of California, where you're going to have a lot of prone areas. But if you're looking at buying a house in this area, taking a peek at this map would probably be a good idea. If I could land a house in one of these white or gray areas, or even maybe like a yellow area, I would probably be pretty good. These are inactive landslides, geologically old. The red and the orange areas are either currently active and having landslides, or they used to, and it wasn't that long ago that they had landslides, so it could be happening again. Let's see. Prevention of large natural landslides. All right, what are we doing? Preventing landslides. Prevention of large natural landslides is difficult, not indifficult, is difficult. And basically, remember that while we can exacerbate some things, the setup kind of has to be there from the beginning. These are natural things that happen, and the really big ones that aren't really associated with human activity, there's not a lot we can do. And that's kind of, you can see that with avalanches. Avalanches aren't caused by human activity. I mean, we can trigger them, but the snow is already there. The slope is already there. There's not really a whole lot you can do. And so we don't even really try to prevent them. With snow avalanches, we try to make them happen sooner and on our own terms. So we go up with the dynamite, plant charges on the slopes, and actually make the snow come down while nobody's there and while we're in control, instead of trying to keep it from happening at all. You can minimize through common sense and good engineering practices. Don't build where you shouldn't build. If you do build in a hard place, make sure you're doing the extra steps to try to make it safe. Drainage control keeps water from infiltrating the slope. Drains can divert water away, and your impermeable layers can keep water from infiltrating the slope as well. They're showing you this right here. They've just put this kind of little cement drain. And so as this is a pretty steep hill, but as it rains, a decent portion of your rain is going to be funneled through this hill. I'm not going to have as much erosion and weathering happening on the side of the hill, and I don't have as much water soaking into the hill and kind of adding that extra weight and gravity and that extra lubrication that could eventually cause a landslide. Soil cement being applied here. I guess what they're doing is taking a side of a hill and just like cementing the whole side of the hill and covering it up, so it's not soaking in anything, and you kind of have a semi-solid layer there. Although I don't know how effective this is going to be. This looks like an iffy operation. So grading can increase slope stability if it's done in the right way. Material from the upper slope can be removed down to the base, and they're kind of showing that here. Although I don't know that they're doing a great job. They are making benches. I would argue these slopes right here look pretty steep compared to the normal slope. And so how stable are they making it? It depends on if they're using the right materials and doing this in an engineeringly sound way. I don't know. Mathematically? No, I don't know. In a way where an engineer, no, I don't know how to say that. We need a word for engineeringly. Engineeringly might be a word. It's just so awkward we don't ever use it. I don't know. Slope supports, retaining walls, concrete, or filled wire baskets. This is a pretty good example here. So we built the road in the mountains. The mountains aren't used to having roads. When we come in, we change all the materials. We cause some problems. And you can see that this area right here has had a landslide. So the road has been undercut. Part of the road has fallen off. They have cones here. You can see where the cement from the road is broken off, and it all went down in a landslide. And so to fix it, they put a concrete wall here, but they know that this area gets a lot of rain, a lot of moisture, and you want that moisture to be able to leave and go down the hill. And so it's kind of like a laundry basket kind of wall. So it has a lot of holes in it, so your water can drain out and continue on its way. Here's another example of like a concrete retaining wall, which is hopefully going to stabilize this hill and keep it from having large landslides. They've also changed the foundation of this house. Instead of just leaving it to sit on the side of the hill, which is probably pretty dangerous, they've drilled down and put deep foundations into the ground to make sure the house is nice and stable. Let's see. Here's a couple examples of different things. So this is a hill that has no retaining wall, and you can see that they're having landslides and losing grass and soil. Here's a hill where they put a couple steps in and made some like kind of rock walls to kind of hold everything in. And then here's another one. This actually might be. It's not. It looks like it could have been the same place, just different part of the year. But no, this is another one where they've kind of built the walls to help retain the side of the hill in place. Obviously, B and C are working a lot better than picture A there. So landslide warning systems, you got to give people time to evacuate. You got to give people time to accept this. Human monitoring for changes in small rock falls. Electrical systems, similar to like your earthquake detection systems, tilt meters, geophones. You're looking for some sort of movement in the earth that you can warn people about. The USGS, which is the United States Geological Society, installed acoustic flow monitors in Washington State to detect lahars, which are basically a mud flow landslide. It's like mud and water mixed together. Wells can indicate dangerous amounts of water in the subsoil. And so there's lots of things you can kind of monitor to be able to warn people ahead of time that the risks are increasing for a landslide, and you might want to consider evacuating. 7-point section, perception of and adjustment to the landslide hazard. Perception of the hazard. Many are unaware of the hazard. They do not think they're at risk. This is probably like a large portion of the people that live along the California coast. It's the same thing here with tornadoes. We obviously worry about tornadoes a little bit, but tornadoes are always something that hits someone else. And unless you've ever been hit by a tornado, you don't feel that urgency until the moment you do, and then you're now part of that group. And so the same thing goes with landslides. If you live on the coast, even if you live in a landslide-prone area, if your particular house hasn't been knocked down or your particular road hasn't been covered, then you might feel that you're not really at risk, that it's just kind of something that happens to other people and not you. And you'll feel that way right up until the moment you join that group. And then you're like, why didn't I know? So homeowners do not think it will happen on their hill. New residents are unaware or not swayed with technical information. So either nobody told them or somebody told them and they're like, yeah, whatever, that's not a big deal. Isn't that kind of the way, not that I'm advocating for buying this, but isn't that kind of the way with like the insurance policy they try to sell you on electronics? You like buy a new TV or like a console, and they're like, we could give you like an extra warranty coverage for 3 years. And if anything bad happens, and we're always like instantly like, no. I'm not paying extra money for nothing bad's going to happen to this. And then like 2 years later, like for me, when your TV goes out, you're like, oh, maybe I should have bought that insurance coverage. Maybe that would have been a nice thing right now. And so, yeah, make sure you got insurance coverage on your car and your house and all the things that you like. And it sucks because you never need it, but then when you do, it's great to have it. So infrequency reduces awareness. So if it's been a while since you've had a landslide or any other hazard, you just get a little bit complacent. So and takes catastrophic events to bring hazard to people's attention. That goes with every hazard and every person. Doesn't matter whether you live in Texas or California or Florida. We all get a little complacent until the moment it's happening. And then we're like, oh no. So adjustment to the landslide hazard. People will continue to build in landslide prone areas. We need to find adjustments. Movement of critical facilities. If people want to build their houses or their neighborhoods there, sometimes there's stuff you can do. Sometimes there's not stuff you can do. People own their property. They have certain rights to build where they want to build. And although you can give them the information, they don't have to listen to it. But for the important stuff, hospitals, schools, police stations, fire stations, those are things that the public should not be allowing to be built in these dangerous areas. If a landslide happens, it's bad enough. If the landslide takes out your hospital and now the injured people have no place to go, that's going to be even worse. Yeah, you gotta make sure that your important stuff is safely protected. Landslide correction. Landslides may be stopped after it starts using drains. Of course, this is referring to like a slowly occurring landslide or one that may be occurring in stages as opposed to just one huge landslide instantly. So personal adjustments. What can you do to stop forest fires and landslides? Uh, get a geologic evaluation of your property. If you're going to buy something expensive like a home, you want somebody to look into this. In Texas, you before you buy a house, you have to have an inspection. Somebody has to come. They check out your roof. They check out your foundation. They look at all the different parts of your house, and ideally, they help you determine whether there's any problems or whether there's any risks. If I were buying a house in California, first off, it would be probably twice the amount of the house that I'm getting here in Texas. And so if I'm spending that much money, I need to make sure that somebody's looking at this. They're looking at the landslide stability of the area of my house. Avoid homes at the mouth of a valley or a canyon. That's not a good place because the valley or the canyon is going to funnel anything that happens directly towards your house. So any floods, any landslides are coming straight for you because that's the way gravity is going to lead it. Consult local agencies. Monitor small landslides on property. So look to see if you have any indicators that a landslide could be coming. Look for cracks in your house, walls, leaning retaining walls, doors or windows that stick. If y'all listen to the radio, right? I know that you've heard this sentence here in Texas because we have bad foundation problems, not because of landslides, but just because we have bad soil and dry seasons and wet seasons. These are the same kind of things. In Texas, your house isn't going to fall down. It's just going to lose its property value. But we look for these same things here in Texas as people in California do to kind of get an idea that they could be getting closer to a landslide kind of area. So looking for cracks in your drywall, doors that don't open or stick, or that change seasonally. Like sometimes in the summer, your doors are fine, but in the winter, they don't close quite properly. That's an indication of a foundation issue, which in Texas is just a pain and going to cost you money. But in a different area, it could be an indicator that you might be in a landslide kind of situation. What else? Be aware of leaks in swimming pools and septic tanks, trees or fences that tilt, sagging or taut utility wires. So if your electrical wire outside your house is like bowing way far down, or if it looks really tight, that's not going to be a good thing. Beware of small springs like water springs that are kind of coming out if you have a lot of land. Look for linear or curved cracks. Look for surface features that could be indicating a landslide. And don't buy a home that has a landslide hazard. That's probably going to be number one. If you know it has something, don't buy it. Awareness for avalanches. We don't really have to go through this. No, if you go vacation somewhere snowy and you plan on skiing, do be aware of avalanches. But most avalanches are triggered by victims or others in their party. Obtain forecasts near avalanche centers before you go out. Most people who survive avalanches are rescued by the other members of their party. So make sure you're going out not with a bunch of idiots, but with people who actually know what they're doing and are somewhat responsible. Ask yourself, is the friend I'm going to ski with someone I trust to dig me out of a snow hole before I suffocate to death? If the answer is no, maybe get some different friends or just stay at the ski lodge. Learn or stay on the nice ski slope where you're not going to have any avalanches, and don't go venture out into the hillsides. Learn avalanche safety procedures and how to evaluate snow conditions before traveling to avalanche-prone areas. And now, finally, towards the end, how much time do we have left? 6 minutes. We can do this. We circle back to the La Conchita landslides that happened in California. It's a small community. Development was limited due to few patches wide enough for them to actually build houses. Appears to be an idyllic location to own a home. There's a high cliff above the community. And so what they're saying is it looks nice, but already there's kind of red flags. They say there's not very many houses because there's not really that many places for you to put a house. It's a very small patch of land that's flat enough for you to be able to put a house. So already you know that you're kind of limited due to the hill and the different terrain around this area. So that should have been your first red flag. Seismic events have caused fracturing of older rocks. And so not only do you have the giant hillside and the risk for landslides, but it's California, you've got a little bit of earthquake activity of seismic events. And so they're slowly cracking and loosening up these rocks and giving you a potential for a major landslide. Cracking visible before the 1995 landslide. Water is seeping into those cracks. Heavy rainfall added to already elevated groundwater level. And so your soil is getting soaked. It's getting very heavy. The cracks are getting filled up with water, which is a nice lubricant. And so you can see what they're talking about. There's just not very much land here to build your houses on. You have this giant hill just above the community. And it's kind of going to funnel everything towards this community. You might have a little bit go to the right or to the left, but there's not really anywhere for any of this rock slide stuff to go other than directly towards your community there. That being said, it's right on Highway 101. I've never been there. I've never even been in the state, but I heard this is the nicest drive you can take in the United States. Right along Highway 101, right along the beach. It's supposed to be amazing. And so, yeah, to live right on Highway 101, there's probably a lot of people that are like, I'll take the risk. We'll deal with whatever happens. But you say that before you've lived through a landslide. And then after one has happened, maybe you're a little bit less convinced. So here's a picture of the town. You can see nice, square little town. Not a lot of homes. Just kind of separated into a couple streets and little neighborhoods. You have the big hill rising behind you. You can see like an active landslide going on over here to the right, the left. And then here's the area that had the two landslides that affected the community. So you had the 1995 landslide was the bigger area. Although that didn't cause as much damage or kill as many people. The 2005 landslide that happened 10 years later was worse, came further into the neighborhood. I think they said it killed 10 people at the beginning. So pretty bad landslide there. Up above the hill, there's an avocado orchard. What are you going to do to your avocado orchard? You're going to water it all the time to make sure that your trees don't die and they're growing avocados. And so that water here is probably filtering down into the slope, helping to create more instability by making it heavier and kind of weighing down that soil. And so there's lots of little things that kind of all add up to this being unstable and kind of dangerous. So study evaluated the risk after the 1995 landslide, found that landslides are common in the area. Landslides beneath homes composed of about 25 meters of landslide deposits, or the land beneath the home. So basically, they're like, you built your houses on the landslides that happened before. It's not going to be good. Here they're just showing their attempts at trying to keep some of the landslide contained with a retaining wall. It obviously didn't work. And then the 2005 disaster happened, and it was because of a lot of rainfall. So not a good time to be them or be there. So we'll finish it up with that. I think we pretty much reached the end. If you have any questions, let me know. And tomorrow I'll talk to you a little bit more about that lab. Wonderful. Everybody have a nice day.
Why is that me? I received it sleep. 5 days.
Okay, we'll end there for today. That's all.